So the next examples that we're going to look at are examples using graphs. So the first example, I'm going to look at a bar graph, and the second example is going to be a line graph. All right, so the first example that I'm going to look at in this set of notes is the bar graph given is the average teacher salary over the following years. All right, so it gives me from 1985, 1990, 95, 2000, 2005, 2010. The bar represents the salary. So in 1985, the salary was $25,000. Again, it's average. Right? And in 2010, the average salary for a teacher was $46,000. The first thing, again, it should be able to understand what the graph is showing you. Right. In general, describe how the average teacher salary changed. And so again, if you look here, from 1985, it grew pretty fast. Or again, it's a faster rate of growth between 1985 to 2000. And then from 2000, it still grew, but if I kind of connect the bars, it's less steep, right? And so it's growing a lot slower in the 2000s. So you can put it in your own words. Over the entire time, the salary got larger, right? It grew. But it definitely grew faster, right? It's faster growth here and slower growth here. All right, so over the 85 to 2000, it grew faster. It's still growing over the 2000 to 2010, but it is definitely a much slower rate, right? It doesn't jump up by as much over those years. All right, and you can put that in your own words. I'll leave that for you to put in your own words in the description. All right, find the absolute change from 85 to 2000. So we're looking at the entire graph. So from 85 to 2010, we're looking at how much did it actually change from those years. So we take the salary in 2000 and 85, so 46,000, 25,000, and find the difference. So 46,000 is what it was in 2010 minus the 25,000 that it was in 1985, and the change was, it almost doubled, didn't quite, but it almost doubled. So it grew by 21,000 over those years. Total, that's the total growth. It grew a little bit over the years, but in total, from 1985 to 2010, the salary for teachers on average grew by 21,000. Right, but how much did that percent change? It should be a pretty big number, right? Because again, it went from 25,000 to 21,000, and it's based off the 1985. All right, so the difference is only 4,000 less than where we started. So remember, the percent change is the change in the salary, right? The function divided by the starting value. In this case, would be the 1985 year. So the change was that 21,000 is how much it changed based on what we started off. And so again, this should be a pretty high percent. It's the majority of the starting time. The starting time was 25,000. If that top number was 25,000, it would grow by exactly the same amount, grow by 100%. So if it doubled, it would grow by 100%. So this should be a pretty high percentage. And it is. It comes out to 84% if I rounded the whole number. So the salary from 1985 to 2010 grew by 84%. 84% of the 25,000. That's how much it grew by. Right? And again, that number should make sense based on... Again, you should always double check that the number makes sense, right? It is the majority of our starting value. Starting value is 25. It grew by 21. That is getting closer to 100%. Right? 100% would be if it grew by 25,000. All right, the last example. All right, so example 5 is a line graph where we're given the population of Illinois from 1818 to 2004. All right, so 1818, 2004. It's in millions, so I gotta keep in mind that it's in millions. All right, so again, they gave you increments 2004, or 1884, 1844, 1846, and so on up to 2000. So it does look like the population of Illinois up to 2004. Now, if this graph continued, it would taper off because our population is declining. But it didn't. This goes up to 2004. I think the Illinois population started to decline around 2010 is when we started to decline in the state of Illinois. So this graph would actually flip if we keep going. But we didn't. It's just going from 2004, so it's a steady increase. Pretty steady increase. There's some dips here and there, but a pretty steady increase. All right, find the absolute change from 1884 to 1904. So 1884 would put me here, 1884 and 19. So these are the two values that I'm looking at. 1884 was 3.36 million and 1904 was 5.13 million. Just in case you can't read that, and that's what those numbers are. All right, so it did grow. It actually grew by a few million. So find the absolute change. So 1994 was 5.13 million minus 3.36 million equals 1.77. And since they rounded all their numbers to 2 decimal places, I'm going to round all mine to 2 decimal places. All right, so it grew by 1.77 million people between 1884 to 1904. So again, this was over 100 years ago, but that was the population growth in Illinois over 100 years ago. Find the average rate of change over those same years. So now we are looking for average rate of change. Remember, average rate of change is the change in the function, so the change in the population, divided by the change in time, right? The input value, that's average rate. How much did it increase per year from 1884 to 1904? All right, so the top is actually that number we found up here. That would be the same change because it's over the same time period. So that would be the 1.77 million divided by the change in time. So 1904 minus 1884. So 1.77 million divided by 20 years. And so that would come out to be, and again, I'm only around 2 decimal places because that's what the whole problem is rounded to. So 0.0, it comes out 0.08885, so I'm going to round to 0.09. And remember, the units on it would be million people per year. So between 1884 and 1904, they added about a million people per year. So remember what that would be? That would be about 90,000 people per year. If I multiplied that by 10 to the 6th, it would be they grew by about 90,000 people per year. All right, the last one. Interpolation, project the population of Illinois in 1900. So 1900 is in between the two values that we're looking for, right? 1884 to 1904, my 1900 would be between those. All right, so we're going to use the same values we're going to be using. We're actually going to use the average rate of change we just found. So that's the average rate of change we're going to use. All right, so every year between 1884 and 1904, they added about 0.09 million people, which again is about 90,000 people. And so we start with the 1884 year, which was the 3.36 million people. You can read that. That's the 1884. And then 1900 is 16 years after that. That's 16 years after 1884, or it's 4 years before 1904, right? 1904. So there's actually 2 ways you can do this. I'm going to do it the way that we've been doing it every time because, again, a lot of times students just want one way to do it. So if we do it the way we were doing it before, I have to add the average rate of change from 1884 to 1900 16 times because it's 16 years between those two. And so I would take my 3.36, add to it 16 of the 0.09 million people. And remember, it's in millions of people per year. I'll put the units at the end. And so when I do that, that comes out to be 4.80 million people per year. Double check that. All right, so 4.84 million people per year is what we would predict the population was in 1900. Now, there is an alternative. You can actually do a subtraction, and I'm just going to show this to you again. I would suggest you do the addition method because that's the method the book does, and that's the method that, again, that we've been using every time. But there is an alternative to this. You could start with the 1904, which was 5.13 million people, and subtract the average rate of change 4 times. Because, again, that's 4 years before 1904. You should get the exact same answer. So 5,013,000 minus 4 times the 0.09, the average rate of change. And so it should come out to the same. All right, with rounding, it comes out to the same. Because it's 4.77. Again, it's because we did round stuff. And so if I round up 4.80 million year. Alright, so there is, again, 2 ways we do it, but typically we'll do the addition year. That's the year that we typically do. Alright, but again, I wanted to show you there is an alternative way if you wanted to do it an alternative way. Alright, so that finishes up 2.1. We will stop there.